I'm presenting on heat band, rain band, and heat low migration, process-based evaluation of 76 GCMs over West Africa. My name is Thompson Annor, and these are my co-authors. Monsoon system is one of the key climate systems over West Africa, and it can be decoupled into the summer monsoon and then the winter monsoon. In the summer season, we have low pressure system over the land, and this brings in a lot of moisture into the land, and therefore the ITCZ, which is the meeting point of the two wind system, is located on the land. And then in the winter season or the dry season, we have a high pressure zone over the land, and this pushes the ITCZ away from the land. According to Biasuti, the mean position of the ITCZ results in a net energy transport from the northern hemisphere to the southern hemisphere. The transport of heat away from the northern hemisphere results in the transport of moisture into the northern hemisphere, and the ITCZ is shifted to the north. This results in a cyclical movement of moisture and heat bands and the heat low over West Africa on annual basis, forming part of the West African monsoon system. So we defined the West African heat band, the West African rain band, and then added it to the already defined West African heat low. So the aim of this work is to assess how the 76 model represents the annual migration of the West African heat low, West African heat band, and then the West African rain band. And the research questions are: how are the models representing the month-to-month location, intensity, and the shape of the West African heat low? How are the models representing the month-to-month intensity and location of the West African heat band and then the West African rain band? Use 76 GCMs, and then these are the reference data set that was used for the work. The Lavisi approach for the determination of the heat low, which is the highest 10% values of low-level atmospheric thickness. And for the heat band, we calculated the monthly mean temperature and then cumulative probability distribution function of the MMTs on all grades, and then found the heat band as the highest 50% values of MMT. Similar way was used for the determination of the rain band as the highest 50% values of the monthly total precipitation. So what is seen in the reference data set is that the heat low is located in the southeastern part of the region and then moved to the northwestern part of the region in August. And then when it is in January, the intensity increases to August and then back to the intensities, low intensities in December. And then also the shape or the form is in a circular form for winter and then summer months. So we look at the models and then we see that the models are reproducing this dynamics, the location and then the intensity of the heat low. However, we see that there are differences in the model simulations. Example is the simulation of the heat low for the winter months, where there are stronger heat lows in the models than the reanalysis products. And then in the summer months, there are weaker simulation of the heat low in the models than the reanalysis product, except the Gs, where there are slightly stronger heat lows at the core of the heat lows in the summer months, which is stronger than that of the reanalysis. And then a unique case is the CNRM model, where we see that instead of circular shape heat lows, we have elongated heat lows for the summer months. And then also in the MPI models, we see that there is a smaller secondary heat lows in the Sahel for the August month, which is not present in the reanalysis dataset. This is the annual cycle for the heat band. So we see that in the reference datasets, heat bands are located in the south in January, and then to the north in August, and then back to January, with an increasing intensity from the south to the north, as we have in the heat low. And a look at the model shows that they are reproducing this dynamics. However, we have stronger simulation of the heat band over the oceans in the models for the dry season months. And then in the wet season months, we have some models that are simulating weaker heat bands. Models such as this one are simulating weaker heat bands, and then models such as GCMs, MPI high resolution, MPI low resolution, MERI models are simulating stronger heat bands. These are the results for the zonal mean heat bands. In the reanalysis product, we see that higher intensity of heat bands are in the south in January and then move to the north in August with the highest intensity, and then back to the south in December. All the models are representing this dynamics as well. However, we see that these four models are simulating weaker, strongest intensity in the summer months, and then these three models are simulating strongest intensity in the summer months as compared to the reanalysis product. So this is the results for the annual cycle rain bands. And then in the reference dataset, we see that rain bands are located in the southern portion of the region in January and then move to the northern part in August with an increasing intensity, and then back to December to the south and then a lower intensity. So the models are also representing all these dynamics, the location and then the intensities. However, the MPI model simulations are showing stronger and then wider rain bands in the summer months, and then also the CNRM model is simulating stronger rain bands over the oceans and then barely no rain bands on the continent for the summer season months. And then in certain cases like this one, we have secondary rain band simulated in the models. In this case, this case, this case, this case, and then that case. So the zonal mean rain band for the GPCP as a reference data set shows that low rain bands are located in the south in January, and the highest intensity rain bands are located in the north in August and then move back to the south in December. So this dynamic is also represented in the models as well. However, we see that the winter or dry season rain band are not captured well in the models. However, the GIS model, the CNRM model, and then IPSL model are simulating the winter rain bands relatively closer to the GPCP dataset. In conclusion, the West African heat low, heat band, and then the rain band migrate from the south in January to the north in August and back to the south in December for a complete annual cycle. And the intensity also increases from the south to the north and vice versa. In general, the models are able to represent the climatological dynamics of all these three features or processes and the linkages between them, indicating a satisfactory representation of the West African monsoon system, although there are differences in the models which are also present in the cases where we use more than one reference dataset. This study therefore presents a crucial pathway for process-based model evaluation for the investigations of future impacts of climate and climate model development. Thank you.